Hey everyone! Today we are going to be writing and identifying subsets from inequalities. Okay, so we have talked about sets before this year. So the sets of numbers like counting numbers, whole numbers, integers, rational numbers, irrational numbers, and even imaginary numbers. So sets are the basis for mathematical language. It's what we group things as. But we can also write sets in different ways. So there's the roster form. Roster, not rooster. Roster form is just a list. So the roster form, this lists the elements, and I hope you're listening to what I'm saying and not watching my writing, the elements of a set within braces. And the braces look like this. So it just lists all of the elements of the set within the braces. For example, if we wanted to have the set of multiples of 2, we would start with the braces, and then the multiples of 2 would be 2, 4, 6, 8, etc., etc., etc. So that's roster form. Set builder notation describes the properties. So it doesn't list the properties, it gives a description of the properties that the element must have to be included of the set. For example, if we were to talk about that same set, the multiples of 2, it would look like this. So notice the braces still, and this straight up and down line, and it is read the set of all real numbers, x, such that x is a multiple of 2. So the set is indicated with the braces of all real numbers x, such that. So we read this line as such that. So the set of all real numbers such that x is a multiple of 2. So let's do an example. How would we write something where x is a set of all whole numbers that are less than 5? Roster notation. So we have to start with our braces, and then we just list all whole numbers that are less than 5. So that includes 0, 1, 2, 3, 4. And that's it, because we can't go to 5. There are no in-betweens. It's just this. Where set builder notation still starts with this, and that's the brace. And then we have our x and that straight up and down line. And then we just state that x is a whole number and x has to be less than 6. And then we end with that brace. So we can read that the set of all whole numbers, that's this part, the set of all real numbers such that x is a whole number and x is less than 6. So we're in the inequalities unit. So here we can solve an inequality and write the solution in set builder notation. So here's my dividing line. I have to subtract 10 because 10 is added. So I have negative 3x equals 30. Divide both sides by negative 3. Oops, and I did the same thing that I told you. I made an equal sign. So less than. I divided by negative 3, so I have to flip that sign. So negative 10. So that's the solution just written as the inequality. But if we wanted to write it in set notation, we would start with our brace, all real numbers such that, and then we would just write our inequality. So when you're solving inequalities, really it is just all about solving the inequality and then writing it in the set notation where you have the braces and the all real numbers such that, unless there is other circumstances like compound inequalities, which we'll get to. All right, the last thing I want to talk about is subsets. A subset is a partial set of another. And this is crooked, let me fix that there. So, for example, if the set B includes these numbers and set A includes these numbers, all of A is in B. So this is a subset of B. So we can say A is a subset of B, and we write it with this fancy-dancy symbol. So A is a subset of B. Another vocabulary word is the empty set or the null set. The null set contains no elements. It's empty. Get it? Empty. So it's no elements at all. And it is a subset of every set. So you have to remember every time that you are listing the subsets, you have to include that empty set or null set. And we can write that in two different ways. We can actually write it as an empty set, or we can write it like this. Either of those are ways that we can write subsets that are empty, so empty subsets. All right, an example like this, what you might have to do is name all of the subsets. So we know it's going to be the null set. So I'm just going to list, oops, that doesn't look very good. I'm going to list it like this. So there's my empty set. And then we have one with 3. We have a subset that includes 4. We have a subset of 5, and yes, I know my braces are getting sloppy. We have a subset that includes 3 and 4, and 3 and 5, and 4 and 5, and this is a tricky one. All sets include a subset that includes all of them. Oh, my goodness. So it would also include the subset of 3, 4, 5, because every set has a subset that includes all of the elements in the set. So those are the 3 main types of problems you're going to have to do for today's lesson.